Hi viewers, welcome to my channel. This is Antony Vijay. In this video, I am going to explain about graph data structure. First of all, I am going to explain the definition part of a graph. So, graph is a non-linear data structure. It is made up of vertices and edges. From this diagram itself, we can easily understand that the graph is a combination of vertices and edges. So, here this round A, B and C, D, E, these things are comes under vertices, and there is a line between A and B. This is called edges. Okay, so edges means there is a line between vertices. Okay, so it can be represented in the form of G equal to V comma E. V is vertices and E is edges. So in this diagram, we will be having how many vertices? It is 5 vertices and we have 7 edges. So let's count one by one. So A here 1, 2 and this is 3 and 4, 5. Totally 5 vertices are there, and edges, let's see. So A to C is 1 edge and A to B is 2 and A to D is 3 and C to D is 4 and B to D is 5 and B to E is 6 and D to E is 7. Totally 7 edges and 5 vertices. This is called as graph. So now I am going to teach about graph terminology. So in this I am going to tell you about the important terms of a graph. So the first important term is vertex. So I have already told you in the previous diagram there are 5 vertices are there, and when I talk about edge, there are 7 edges already available in the previous diagram. So usually edge means it's a connection between two different vertices. Okay, so A, B and there now here A and B are vertices, and between A to B this line is called as edges. Okay, this is the important term of graph. And when I talk about types of edges, there are 3 different types of edges are there. One is undirected edge, the second one is directed edge, and the third one is weighted edge. Let's see one by one. So first we will be going to see about undirected edge through graph diagram. Okay, so see this diagram. So I have differentiated these 3 diagrams. Okay, so this one is weighted graph, and this is directed graph, and this is undirected graph. So weighted graph means what? We are assigning a weight between 2 different vertices. So here the weight between 1 and 2 is what? 5, and 1 and 3 is 3, and 2 and 3 is what? 1. This is the weight. Some weightage we are assigning between every edge. Okay, likewise when I talk about directed means what? It is a unidirectional. Okay, it's a unidirectional. Okay, it means there is only one side we go for it. Okay, so this is called 1 to 2. Okay, and 1 to 2 there is a connection is there, and 2 to 0. Okay, 2 to 0 and 1 to 0. This is the 3 different connections are there. Okay, so this is called unidirectional. But when I talk about undirected graph, it is bidirectional because there is no direction at all. Okay, this is a bidirectional one, so that 1 to we can go for 1 to 2, 1 to 2 also possible, and 2 to 1 also possible. So 1 to 2, 2 to 1 also possible. Likewise 1 to 0 also possible, and 0 to 1 also possible. Likewise 2 to 0 also possible, 0 to 2 also possible. This is the different types of edges in the graph. So let's see the other graph terminologies. Third important term is origin. So origin means, so it's a starting vertex. For example, here I have 3 different nodes. Okay, nodes, so you can call it as nodes or vertices. Okay, so I am drawing like this. Okay, so for example, if I am going to travel between A to C. So I am choosing a path from A to B and B to C. So here starting is what? A. So A is a starting. That's why it is called origin. It is called origin. Okay. And the destination is I'm going to start with A and through B I am reaching C. So C is a destination vertex. Okay. So this is called origin and destination vertex. This can be applicable only through directed graph. Okay. So this is only happen with the help of directed. So with the help of undirected, it is feel difficult. So that we are using directed graph like this. Okay. So when we talk about the another term is called adjacent. So adjacent means if there is a edge between two vertex. For example, there is a edge between A and B. So A and B are adjacents, and B and C are adjacents, and C and A are adjacents. So these are the adjacents. So what about outgoing edge? So outgoing edge means this can be only happening in the directed graph only. Once again I am drawing a graph like this. So A, B and C. I am taking three vertices. So three edges is there. Okay. So this is outgoing edge means, so I am drawing like this. Okay. See, A is having two outgoing edges. See, this is a one outgoing edge and two outgoing. So A is having two outgoing edge and C is having only one outgoing edges. Okay, so A is having B as well as C, two outgoing edge. For B does not have any outgoing edge, and for C having only one outgoing edge, that is C to B. This is called outgoing edge. So what is mean by incoming edge? So in this diagram, A does not have any incoming edge, but B is having how many incoming edge? Two incoming edge. So B is having two incoming edge and C is having only one incoming edge. This is called incoming edge. Okay. So what about degree? Degree means it's a number of edges connected to a vertex. Okay. For example, so we have to consider degree of A. Degree of A. So degree of A means we can say it as total number of edges connected to a vertex. So see here, so when I talk about degree of A, so A is having 1 and 2. So totally we are degree of A means what? 2. So 2 number of edges connected to a vertex A. So when I talk about degree of B, here also B is connected with two edges. So from one edge A is coming and another edge is from C. So again it is 2. And for C, how many edges it is connected? One from A, so another one it is outgoing from C to B. So B also 2 and C also 2. So two different edges are connected like this. This is called degree. So what is mean by in degree and what is mean by out degree? Okay, so generally speaking, degree means, for example, A, B, C. Okay, so I am drawing a graph like this. So when I talk about degree now, we can draw it is a directional, it is better. So the degree of A, degree of B and degree of C, it means degree of A means, so how many edges are connected to the vertex A. So there are two vertex, 1 and 2 vertex are connected with A. So the degree of A is what? 2. What about degree of B? Again here 1, B is connected with one vertex and again this outgoing vertex. Okay, so 2 degree. and for C also one from A and one from B. So totally this is called, generally we are speaking degree. But when I talk about in degree and out degree, in degree means incoming degree. So how many incoming degree, how many outgoing. So incoming means what? Incoming means how many incoming degree for A. Incoming degree for A. So only A is having outgoing degree, only no incoming degree. So incoming degree is what? 0 for A. And for incoming degree for B is what? How many incoming degree is there? So one from A. Okay, so only one. Okay, so for B it is only one. What about incoming degree for C? C is incoming degree from A and one from B. So totally how many incoming degree for C? It is 2. Okay, this is called incoming. So outgoing means what? Outgoing. Outgoing. Outgoing of A means, so how many degree, how many nodes are outgoing? Okay, for example, from A to, there are two edges outgoing. Okay, so A to B, one line is going now. Likewise, A to C is another line. So totally how many outgoing? It is for A it is 2, and for B it is only 1. It is only 1. Okay, only one outgoing is there. And for C it is no outgoing, only incoming. So it is 0. So there is no outgoing. This is called out degree. Okay. Next we will see about the self loop. Self loop means what? For example, we have a graph like this: A, B, and C. So I'm having a graph like this. Okay, and sometimes for example, a vertex having self loop like this in this line. Okay, so A, so sometimes we have to form a matrix. So on that time we have to assign a value. Is there any self loop? So in this particular 3 vertex graph, A to A is 0. A to A is 0. So here we are representing in the form of Boolean. Boolean means we can take 0 or 1. 0 means there is no link. If there is no link between A to A, it is called 0. But see here, this is the symbol for self loop. Self loop means we have to rotate like this. Okay, so we are having B is having a self loop. So B to B is 1. So B to B is 1 means one connection is there. It means one link is there. If it is 0, no link. If it is 1, one link is there. C to C, C to C, no. Okay, no self loop. Okay, self loop means what? So it is like a particular vertex. It is keep on coincide with each other. Okay, and a simple graph should not have any parallel and self loop edges. If a particular graph is having no parallel edges as well as no self loop edges, that particular graph is called a simple graph. So see here, so in this graph is not a simple graph because B is having a self loop. B is having a self loop, so it is not a simple graph. So if any graph is no parallel edges and no self loop edges, it is called a simple graph. Okay. Now we are going to see about the representation of graphs. There are two different ways we can represent the graph. One is adjacency matrix and the second one is adjacency list. So let's see one by one. So first we will be going to see about adjacency matrix representation. So here I told you already. So this particular matrix will be forming with the help of Boolean only. So zeros and ones. 0 means no link. 1 means if there is a link, it will be represented as 1. So if there is an edge between two vertex I and j, it will be represented as 1. if there is no edge between vertex I and j, it will be represented as 0. So it will be in the form of matrix. So it will be like 0 0 0 1 0 2 0 3 likewise. So in the for loop we will be taking care of like that. Okay. So see in this diagram, totally we have 5 vertex. So we are forming 5 cross 5 matrix. Okay. So based on the number of vertex, we are forming a matrix. So 5 vertex, so 5 cross 5 matrix we have to follow. So A to E we are following. So A, B, C, D like this. Likewise, column wise as well as row wise we have to put. So as I told already, if there is a self loop between A to A, we have to assume 1. But A does not have any self loop. So it is A to A is what? 0. And A to B. A to B. Okay. Is there any link between A to B? Yes. There is a link. There is a link between A to B. So we have to assume 1. I told you already. If it is 1, there is a link. If there is 0, no link. Likewise, A to C also we are having, and A to D also we are having. Likewise, we have to mention A to C, A to D, and A to E, no, 0. It means what? There is no direct connection between A to E. So it is only happening through B only. So A to B and B to E. Okay. So if there is direct connection between A to E, now we have to put 1. Otherwise, we have to put 0. And for C, so B to B, see here, B to B, there is no self loop. Okay. And B to C here, so B to D is there, B to E is there, B to A is there, but B to C is no connection. So it is 0. Likewise, C to A. C to A is there. See here, C to B. C to B, there is no direct connection. So 0. C to C, there is no self loop. And C to E here, 0. C to E, there is no direct connection. And for D, D is connected with all the nodes. See here, so D to D, this one is self loop. This one is self. See here, this small circle is called a self loop. Okay. So it means there is a connection between D to D. Okay. So next one is E. So E to A, there is no connection between E to A. So we are mentioning as 0. And E to C also 0. And E to E, there is no self loop. This is the representation of adjacency matrix. So in this diagram, I am going to take directed graph. So previously we have seen undirected graph. So now I am going to take about directed graph. So here in this directed graph, there is a unidirectional one. I told you already. If there is a direction, so it is supposed to be unidirectional. So no bidirectional. So here when I talk about 5 vertices, so 5 cross 5, again same thing to be followed. So the only thing is the arrow, that is called unidirectional. So A to B, and so here A to B it will be 1 and A to C is 1. So A to D is 0, A to E is 0, so all others are 0. Okay, keep in mind. And for B, so B to D is 1 and B to E is 1. Okay, B to D and B to E is 1, all others are 0. And for C, only C to D is 1. Okay, C to D is 1. And for D, so D is already having self loop. So D is having self loop and D is connected with E. Okay, no other. Okay, so D is connected with E. So D is 1. Okay, keep in mind. And for E, so there is no outgoing edge. There is no outgoing edge from E. So keep one thing in mind. So when I talk about directed graph, we have to consider only the outgoing edge. So no incoming edge to be considered. Okay. So if there is an edge, we have to mention as 1. Otherwise, we have to put as 0. This is the form of a directed graph. The second representation is adjacency list. Okay, so in this we are taking the same graph having 5 vertices. So here A is connected with B as well as C. So this representation will be like this. Okay, so here A is connected with B and C. After C, there is no connection. After C, there is no connection. That's why we are crossing out like this. Okay, and for B, so let's see the outgoing edge. Okay, so for B to D and B to E. Okay, so we have to draw like this. So B to D and D to E. After that, no. Okay, after that, C. So C, we have only one outgoing edge, that is D. So we have to cut like this. Okay, and for D we have A as well as we have A as well as we have E. Okay, and it is also having D also. It is also having D. So D is having A, D self loop. See, we have to mention the self loop itself. Okay, so D is connected with A, and D is having self loop, and D is connected with E. So totally 3 vertices, and finally we have to cut like this. And E, so E does not have any outgoing edge, so that we have to cut like this. This is the representation of adjacency list. Okay, this is the introduction part of graph data structure. In the upcoming sessions, we will be going to see about the important topics of graph data structures.
Please like and subscribe to my channel and press the bell icon for regular updates. Thank you very much for watching.